So this talk has kind of an interesting name, Whispers in Chaos. And so you might think to yourself, well, okay, what do we mean by chaos? And actually, we're going to be talking about incidents today. So I want to do a little survey of the audience. It's always a good thing to start off with. Raise your hand, keep your hands up if you are an operations engineer that deals with incidents. Yeah, all right. And keep your hands up. Raise your hand if you're a developer that gets pulled into dealing with incidents. And raise your hand if you are neither of those, but you care about incidents because you want to know when the website's going to be back up. That should basically be everyone in the room, right? Yeah. So that's what we're going to be talking about tonight. So, question for all of you: how do you know an incident is occurring? Any thoughts? Any guesses? What? Yeah, monitoring. Like that was not a trick question. You know, someone in the back's probably like screaming, "Node!" Incidents are happening because of Node. No, because of monitoring. So that brings us to an interesting question. Okay, so we have monitoring to help us know when an incident is occurring, but how do we know what to do when an incident is occurring? And that's actually what we're going to be talking about today. And the different take that we're going to be looking at is how we as human monitors and human sort of monitoring tools, how our brain works when dealing with incidents. So as was said earlier, I'm J. Paul Reed. I'm not going to go through this slide. It has my Twitter name on there, so if you would like to chat with me about things on Twitter, you totally can do that. I will also mention that I'm a Master's of Science candidate in Human Factors and System Safety, and I mention that because a lot of the stuff that we're going to be talking about today comes from the safety sciences and a lot of the work that's been done there, so a lot of this work comes from that field. So back to this question of how do you know what to do when an incident is occurring? So the first part to answering this question is to actually look at how the human brain processes information and how it goes about reacting to stimuli. And there's been a bunch of work that's obviously been done on this. And one of the most common sort of ways that they describe this is there's sort of two brain systems that we use. One is automatic and very quick. It doesn't take us a lot of effort to actually use it. And there's actually little sense of voluntary control. And I'll have a couple of examples where you'll kind of see that. The other one is described as sort of more effortful. We use it for complex computations, complex analysis. And there's a lot of sort of, it's related to concentration, choice. I always find it interesting that they describe it as agency. This is detailed in Daniel Kahneman's book, which is actually a very thick book, but it's a very good book. And this book actually talks about most of the work that he did as a psychologist for his career. So it's actually a pretty thick book with lots of different experiments that they did over the course of his career to kind of show this. So what am I sort of talking about? Well, in the first the type of problems that our brain uses the first system to solve, are problems like orienting to the source of a sound. So the sound of my voice if you were turned in a different direction and I said something you wanted to find me. Completing phrases like bread and butter, right? 2 + 2, what does that equal? 5, exactly. Finding a strong move in chess, surprisingly, is the system one thinking, but only if you're a chess master, which is kind of interesting because that's going to come back. We're going to come back to that later. And again, this is called system one thinking. The other system, so focusing on a particular voice in a crowded room, like if you're at a party, that's system 2. Counting the occurrence of the letter A on this slide. Filling out a tax form, and then checking the validity of a complex logical argument. I'm kind of amused that filling out a tax form was like higher on the list than validating a complex logical argument. One of the distinctions they make with system 2 is they say that these things require attention, and more than that, when they are disrupted, or they are disrupted when we lose attention. So if you think about that, if we're working on our tax form, or we're at a party and we're focusing on what somebody is saying, and then maybe somebody yells and startles us and draws our attention away, it then becomes impossible for us to do system 2 type tasks, and we actually have to get back to concentrating to be able to do those tasks again. And again, these are called system 2. So, but it turns out, obviously, the human brain is more complex than that, more complicated than that. So we're actually going to look at some other research that's related actually specifically to our domain. Who here knows who John Allspaw is? I see some yeah, about half the room. He was the CTO of Etsy up until last month. He was also the program coordinator for Velocity. He wrote the web scaling book. He's written a couple books. And so he did his work for his master's, same program actually, on the question that we're talking about. How do engineers go about figuring out how to deal with a particular incident? So his thesis was trade-offs under pressure, heuristics, and observations of teams resolving internet service outages. So what he did when he worked at Etsy was he actually took a specific incident that Etsy was dealing with and deconstructed it, which is kind of interesting. The incident in question, I'll tell you a little bit about it. On December 4th, during their busy holiday shopping season, they found out at 1:06 in the afternoon that the personalized homepage for users that were logged in was having trouble loading. The load times for that particular page were going way up. So how many people are familiar with incident response and actually kind of retrospectives? A lot of people put their hands up that they get called into incidents. Do you also do retrospectives after? Yeah? Okay, good. So this is probably familiar to you because we talk a lot about timelines, creating a timeline. This is out of Sidney Decker's book on Field Guide to Understanding Human Error. So example of a contrived timeline. And you probably do something like this when you do your own retrospectives for incidents. So what he did is he actually did kind of a timeline on steroids for everybody involved in the incident. So this is from his thesis, and it actually shows he was able to collect data of what the engineers actually looked at, what pages they loaded from the internal infrastructure, so dashboard access, Princess requests has to do with, it's their deployment tool, I believe. So they were looking at sort of what was deployed. And also like in their staff directory access. He was able to do this for basically every single engineer that was involved in the incident. And there were about, I think, 7 engineers that he did this mapping for. Of course, software is a team sport. So he also actually mapped, Etsy does a lot of sort of chat ops like work. So all of this happened in an IRC channel. So he actually mapped to all of the engineers that were involved when they said things in IRC to actually put all of that data together and look at it. So he identified 3 what I would call monitors for the purposes of this talk. But they're really heuristics that engineers use to work on incidents. And before we go through them, actually, I would, you might ask yourself, what do you use? What would you describe as your heuristics? And see if any of the ones that he found match or if they're weird and odd to you, because I think that would be really interesting. But he was able to identify these 3 pretty much among every engineer that worked that particular incident. So heuristic number 1, change. Basically, what has changed since the system was in a known good state. So that would include, did anybody do a deployment? Did anybody commit anything? But it also includes things like network changes, infrastructure changes, external things. If you're on AWS, did S3 go down? Because that never happens. So looking at what changed. That's the first heuristic that engineers use. If that doesn't solve their problem, and in this case, by the way, it didn't, nobody had done any deployments, then the engineers describe this process of going wide. In other words, what in my known universe could have caused the problem that I'm seeing? So it was funny, one of the engineers described it as going very broad, lots of breadth, and then when they see something that they find that grabs their attention about what it could be, they immediately switch to going very deep. And they look at that problem very deeply and they kind of chase it to the end. And then if it's not the solution, if it doesn't confirm their hypothesis or doesn't give them any benefit in terms of solving the problem, they go back to being very broad. So this process of very wide and then very narrow and then going back very wide if it's not fruitful in their search. And then finally, heuristic number 3 was something he called convergent searching. So what signals do I know about right now? In other words, what signals is a monitoring tool myself as a human with a brain that can deal with things that AI can't? What signals and heuristics am I receiving that can confirm or disqualify, and that's actually important that it's either, my current working diagnosis? So if I think I know the solution to the problem, I'm going to be looking for things in the system that I'm working on, these, again, heuristics or weak signals, that either confirm or disqualify what my hypothesis is. Now, it was one of the interesting things that he found, and I would argue this is probably the most interesting part of this research, is when we do this, we're confirming or disqualifying things that come to mind from either a specific past diagnosis or a general and recent diagnosis. So what does this actually mean? Well, it actually means either a really, really painful incident memory or an incident that I would say is still in your L1 cache. And so what we mean by the first one is we will recall things that were incidents that like we will remember for our entire career. They were so bad that we will take them from job to job and go, yeah, remember that one time? It was, web accelerators or whatever it was. And we will often go back to that. And then the other one is incidents, if we're sort of actually biased to look at the signals that we're receiving through incidents that we might know but that are recent. So maybe the last 2 weeks, 3 weeks, the last 5 incidents that we worked. Something that's still fresh enough in our memory. We're going to look at a couple of really actually interesting examples of where he saw this and why he kind of was able to describe it this way. And again, what we're doing when we use these two heuristics is we're trying to confirm, disqualify things that we're seeing in the system about our hypothesis. Okay, so this incident. As I said, the page load times were increased, and eventually they narrowed it down and were able to discover that it was caused by CDN cache misses that were due to an HTTP 400 status in an API, so the CDN wasn't caching the result because it was a 400, from a closed store. So Etsy, if you know Etsy, is kind of like eBay, so people can have stores where they sell products, and the stores can be closed for a number of reasons. Maybe they didn't pay their bill, maybe they've left, right? So the store was closed, referenced by a blog post in the sidebar. So the point is, somebody made a blog post that referenced a store that had been closed, which caused the API to give a 400, which caused the CDN to not cache the result, which caused the slowdown because nothing was being cached. So as you can see, remember I said nobody had done a deployment, nobody had done a commit or change into any code. It was actually somebody did a blog post, and it turns out that their profile information, actually an Etsy employee, had a store that was closed, and that's what was causing this problem. So this is from Allspell's thesis, and this is what's called a process trace. So you'll see there's time up top, and then there's a bunch of different engineers. Those are the different colors and shapes. And then what they thought, and actually the circles and the squares are hypotheses that are looked at and then tested. So that is an example when John went and talked to this person about it. That's an example of a heuristic where one of the first incidents that engineer had worked, and I think they had been working there for a year at that point. One of the first incidents that they had worked at Etsy was a frozen shop problem. So that's an example of something you remember, at least maybe not for your career, but at your time at a particular organization. Oh yeah, that first thing that I did that was an outage caused by frozen shop. So he tended to ask that question. When John went back to interview that particular engineer, he started describing this incident, saying, hey, do you remember the incident on this date? Do you remember what you did? Blah, blah, blah. And the engineer started talking about, oh yeah, that was the varnish incident, wasn't it? And that's an example of the other case where that engineer had actually been dealing with varnish incidents for about the past month because they had had varnish problems. In fact, he'd been dealing with that so much that when this incident came to mind, he misremembered that it was a frozen shop issue, and he misremembered it as a varnish issue, which actually I think is pretty fascinating in the way our memories work about that sort of thing. John also found a bonus heuristic around testing the fix. So I want to do another survey. How many of you, when you do a deployment, as a rule, make sure that the tests passed first? All right. Few hands going up, right? Now, a question that I have for you, for those that put your hand up. Now, imagine you had an outage, and you made a one-line config change to fix the outage, and you committed it. Would you wait? Raise your hand if you would wait for all the tests to pass before you then deployed that one-line fix. It's interesting. Yeah. So this is good, right? I see a lot of people doing this. We actually asked that. And I think this graph is very interesting, right? 1 is I would never wait. 5 is I would always wait. And what he found is that actually most people would sometimes wait. There's the 2s and 3s are mostly when. I particularly find it interesting, actually, that the 2s are higher than the 3s on this. So the tendency to wait is actually a bit lower than you would think. I also actually find there's one engineer who will never ever wait, no matter what the change is. Okay, that's cool. That's kind of funny. The heuristic that he basically discovered here is that we actually sort of use heuristics when we push fixes. So we won't rely, most engineers won't rely actually on formal unit tests and a formal CI run when they're under pressure for an incident, if they can localize the change and they feel like they understand it, and if somebody reviews it. That's generally enough confidence for most engineers to actually push a change. It's kind of an interesting finding. And a lot of this, by the way, I'd point out, I see a lot of people nodding their heads. A lot of this seems kind of intuitive. And when we talked about this research before, people are like, yeah, that makes a lot of sense because it's what I would do in my job. And I would point out what's interesting is that this hadn't been studied at all in the system safety area, specifically with respect to IT. So even though people are nodding, which is great because that means the research is at least somewhat confirming what people seem to do, we didn't actually know, we didn't have a good handle on accurately describing like how we think about these problems. So a question for you, how do you get better at detecting an incident is occurring? Any thoughts? Monitor things better. It's still not a trick question. Like if somebody's like, go containers, no, just monitor things better. So then the question is, okay, how do you get better at knowing what to do when an incident is occurring, right? We've been talking about, well, how do we know what to do? How do we get better about knowing what to do? So there's a couple of researchers named Hoffman and Klein who came up with a bunch of research on expertise. What does expertise mean? And they basically described elements of expertise as people that can use a knowledge base to describe typicality, make fine discriminations when they're making decisions in the activities that they're doing. They also rely on this idea of mental simulation. So they basically will, when they're searching for paths of solutions, they'll say, well, if I do that, it's probably this is gonna happen, and then probably that's gonna happen, and then probably that's gonna happen, right? And we all do that probably if you've worked an incident. You think to yourself, okay, well, if I reset the servers, if I do a rolling restart, what do I expect to happen? Because we've probably done that before. One of the interesting ones is then experts also use knowledge base to apply higher level rules. And that's actually something that novices don't do for lots of reasons. But that is one of the elements of expertise. This is something that I think was very interesting in their research. Experts don't look for what's there. They actually look for what's missing. So if you're working on an incident, they're really good at detecting things that aren't there that should be. And then they go into detail explaining that. This is a great quote from their paper. But that was something that sort of was unexpected to them, right? Experts, it's not that they know what to look for. They know what to look for that isn't there, that should be there. So how do we do this? How can we provide these sort of useful experiences to increase our ability to sort of detect these things, again, as human monitors? People probably heard about the 10,000 hour rule, right? This was discussed at length in Malcolm Gladwell's book called Outliers. Now, you might say to yourself, yeah, but Malcolm Gladwell, he's just kind of, he tells these stories and there's no science. I would point out that for this presentation, I actually read the paper on which that book was based. It was by a researcher named Anders Ericsson, and it was the role of deliberate practice in the acquisition of expert performance was the name of the paper. One thing that I would note was very interesting about this researcher after Outliers came out actually wrote a rebuttal paper to everybody that was basically yelling at Malcolm Gladwell, who basically took his research out of context. And so he wrote a paper saying, yeah, I know, Malcolm Gladwell took it out of context. But if you look at the original paper, what they found is that there is this idea of 10,000 hours of whatever the activity is over 10 years had a statistically significant impact on people's ability to perform a particular activity. Now, what's interesting, and this is where I think Malcolm Gladwell sort of extended it in ways that may not actually be valid, these were for what they studied are relatively stable systems. So what that means is sports, music, this is why chess works as system one, because the rules of chess don't tend to change. And same thing with music, right? When you're practicing over that 10,000 hours, those systems are relatively stable. As an example of expertise in other crafts, people are familiar with the Miracle on the Hudson incident. A couple of things about that story to kind of give an illustration of what this is. So that's Captain Sullenberger there. One of the things he did when the engines stopped turning is he immediately started the auxiliary power unit, which, by the way, is something like step 15 on the checklist. That saved a lot of people because it ended up powering the aircraft, and it made them able to move the control surfaces of the aircraft, even though there was no power from the engine. So that was super important, and it wasn't on any checklist until way down. But he just did it as the first thing. Taking control of the airplane, he immediately took control of the airplane. You might think to yourself, well, he did this because he's the captain. And actually, that's not why he did it when they talked to him about it later. The reason he did it is because he had been flying the A320 for something like, I think it was 5,000 or maybe 8,000 hours. And so he was very used to managing the energy in the aircraft, right? Having an intrinsic sense of what the weight is, how far they could glide without engines, that sort of thing. The co-pilot had actually just checked out on the A320, and so he didn't have as good an intrinsic understanding of that, but Sully asked him to run the checklist, get out the quick resource handbook and run the checklists, and he had just been learning all that because he had just checked out on the aircraft like 200 hours ago. So he basically rearranged their roles to be what he thought they would be most effective at. And then not attempting to land at LaGuardia and return to the airport. If you fly, I'm a private pilot, you're kind of always taught to make an airport if you can. And he decided not to do that. And I think the results would have been, well, actually they showed they would have been disastrous had he done that. So this is what expertise looks like in aviation. This is expertise in ops. A little haiku. Something we've kind of learned. So how do we gather this? Experience and turn experience into expertise? Again, going back to Klein and Hoffman, they describe different types of experiences, right? So personal experiences, that's what we would consider maybe the job in our context if we're engineers, right? Just being able to be challenged in a particular context and work through those challenges. Directed experience. So one of the interesting examples that they talk about is receiving tutoring, not so much so that you get the tutoring, but receiving enough tutoring so that at some point you can actually be a tutor, is what they're talking about there. Manufactured experiences, that's training and simulation, and then vicarious experiences, that's painful, memorable events that we actually, and this is the other thing, we craft into stories, right? We tell these at the bar on a Friday happy hour or something like that. Now, in an operational context, what is this? Well, personal experiences, that's like being on call, right? The directed experiences, one of the things I'd point out, that's code review, right? One of the hardest things to learn is to give good code review feedback, and one of the best experiences you can have as a new engineer, especially maybe one that just came out of college, is getting good code review feedback. But a good measure of that is, over time, are you able to give good code review feedback? Game days and chaos engineering, there's a lot of talk about that right now in the industry, but that's a manufactured experience. And then, of course, vicarious experience. I remember this one incident where it was DNS, because it's always DNS. So that's one way to do it, 10,000 hours of experience. The other way to do this is what's called exploring discretionary spaces. So this is what's called the Rasmussen Triangle. It was by a guy, the guy who came up with it was a safety science researcher. He studied 3 Mile Island, was his big claim to fame, but he came up with he's kind of one of the big league people in the safety sciences. He came up with this, and basically, like most triangles, there's 3 sides to it, 3 boundaries. The boundary on the bottom is the boundary of unacceptable work. Actually, no, I want to start with the boundary on the right. Boundary of economic failure. So that boundary is the boundary that we would not do the activity because it would be too expensive, right? So in other words, some project that we might do, it's too expensive, so the business wouldn't pay for it. The boundary on the bottom is unacceptable workload. That's humans are lazy, and I don't mean that as an insult. We are sort of evolutionarily trained to get the most out of a gram of sugar in our brain, so we just try to find the best, easiest way to get the most amount of work done. And then that other boundary is the boundary of functionally acceptable performance or acceptable risk. When we cross that boundary, that's when we have an accident. So there's these things in his model called pressure gradients. One of them is from the business, cheaper, better, faster, right? So that's pushing us, the business wants cheaper, better, faster. Makes sense, right? us as humans in that system, we want the maximum work for the least amount of effort. And you might notice, where are we both pushing that system? Yeah, we're pushing it toward the boundary of an accident or incident. Now, teams that are really good at this are good at what's called exploring that discretionary space, right? And a lot, there's a dotted line there because a lot of the diagrams that show this have one. And basically, teams that are good at this, they get really good at knowing when the system is about to have an accident. That's all heuristics, right? And the way we get better at that is exploring that discretionary space to figure out where the boundary is as a team together when we're working on these complex systems that we operate. This is right out of the SRE book, and I thought it was really interesting because if you look at the bottom, monitoring is at the bottom, incident response is right up from that, and then postmortem and root cause analysis, which is kind of what we're talking about, is right above that. I find it really interesting that from an SRE perspective, Google says those are the most important things. And as people who are interested in monitoring, this should make you all feel really good, right? That monitoring is like the base level of all of that. So one of the things I wanted to mention, Etsy has a debriefing facilitation guide, and one of the really interesting things that they talk about when they're doing retrospectives and when they are basically working to learn and explore that discretionary space together, they don't worry so much about remediation items. They don't worry so much about, okay, what's the code fix for this, or what's the policy or process change we're going to make. They end every retrospective, or debriefing they actually call them, with these two questions. Did at least one person learn one thing that will affect how they work in the future? And then did at least half of the attendees, would they want to do whatever that process was, would they want to do it again, right? And because basically what they're saying is that it's important, what is important to them is not, we got the 18 bugs filed in Jira that we know we need to fix. It's, did someone learn something that they'll be able to recall in the midst of an incident that will help pivot the incident in a good, useful way that has actually results in a better outcome? And only one person needs to do that. Remember that original engineer who said it was frozen chop and kept saying it was frozen chop until somebody listened to him? Turns out he was right. And then the last question is, they ask that because if nobody likes doing retrospectives, you're not going to get a lot of positive involvement, and people won't want to do them, so they want to make sure that it's a good experience for everyone. So, I started this section by asking, how do you get better at detecting an incident is occurring? And the answer is, create space and experiences to facilitate the cultivation of ourselves and our team so as to improve our collective heuristics at detecting weak signals and ambiguity in the complex socio-technical systems in which we operate and exist. Or, another way to say that is, practice makes better. It does not make perfect, it makes better. This concept of expertise that recruiters and companies want, it takes time and space to develop that. So create that time and space. And finally, I don't know if people recognize this picture from the opening slide. It's actually a picture, it was the last picture that Voyager took leaving our solar system. So that dot there is us, it's the Earth. And it's just us out here amid the chaos, right? It's just us and our teams operating these systems, monitoring them with heuristics that are really hard to teach computers, right? It's just us out here doing that. So be good to each other on all of our collective journey as individuals and as a team to expertise. Thanks. So it actually turns out that the infrastructure engineer that talked about the closed shop voiced that a couple of times. Nobody seized on it. Nobody kind of really listened to him. So he actually started investigating it out of band to collect evidence. So that was an example of very broad, and then he went very deep. And he went very deep very early so that he could provide evidence to the other engineers. I think, and I'd have to go back and read the narrative of the thesis where they talk about that, but I think most of the engineers were still trying to make sense. So at that point, they were pretty broad. And when he got the first engineer with the frozen chop got pretty far down that path of confirming that, or trying to confirm that, that's when the other engineer kind of brought up the varnish issue. But again, it's fascinating, isn't it, that was what he had dealt with, I think, for the last 2 or 3 weeks. So to him, he was thinking, oh, I know this is a varnish issue. This is a great conversation, right? Because what you're basically talking about is, we talk about a socio-technical system. That's the socio part. That in a team dynamic, we might let an engineer, who, by the way, might be more senior, tell us those things, and we're like, oh yeah, it's that. Or maybe not. Maybe a junior engineer is saying it's that, and they're right, but we don't listen to them. So this becomes, how do we, as a team, get better at working with each other to have better outcomes? But yeah, that's a great question. Cool. Thank you.